I know that there's been a lot of discussion previously on the issue of should there be some sort of integrated database for holding the descriptions of parts, or should we be thinking about them more as pieces of paper that we hand around and send to each other as documents. And I'll put my cards on the table. I think we need a database, and I think the idea that that you have these sort of free-flowing documents wandering around on the web where you don't know what version it is, you don't know whether the version's current or not, I think that's a bad strategy. And it also means you never know how many parts you've got, and where to go find it. Do you talk to Joe, your neighbor, and hope that he has the document you need, or do you go to a central place that tells you, what's available? There's implications about linkages between documents if we have the individual document style, and we should discuss that. There's, I think, a lot of confusion about what a part is, and I'll again preface my brief comments with my personal views. I think a part is much more than a DNA sequence. And I know there's people who have the opposite point of view, that the DNA sequence is the part, is the DNA sequence, and that's I think I see the reasons for that, but I disagree with it. And in my mind, a part is a functional object. I don't care whether when I go to pick up an electronic resistor, whether it comes in a package suitable for assembly into a cell phone, or whether it's something that you build vacuum tube computers out of. It's the function and it's the description of what it does that matters to me, and a few key parameters. How much power can it dissipate? How much resistance it has? Those are the things that matter to me, and the details of how it's made, what material it's made out of, they don't matter, or they usually don't matter. And that's true of electronics. It's true, I think, in biology as well. So yeah.
You raise a very interesting point, because I think a lot of us are confused on these names. You have part, device, system, and it's interesting that that's what you say. It seems to make sense to me.
So I think we can have a good discussion on this. I'm not trying to have the discussion now. I'm simply saying that we ought to have this discussion. There's, I think, a real opportunity to standardize some of the things that we don't think about as parts of parts. I know that we've had this discussion partly before, but there ought to be a standard way of saying what the IP issues are with a part, and that ought to be part of the description. We're nowhere with that right now. I think that's part of a more general problem with IP, and I can tell you my short version of that. The short version from my standpoint is that if you ask a lawyer whether or not this part is something you can use, the answer will always be, I'm not sure. And that pretty much is always the answer. And you can pay money and spend lots of time and get that answer, or you can just assume that that's the answer that you're going to get. And that's a very unfortunate situation. I think we have a real problem, and I have some ideas on what we might do about that, which we should spend some time talking about. The fundamental one, which I am looking at closely, is the idea that we might look very carefully at parts that are, and at technologies that are coming off patent. So, if you think 20 years ago is 1988, PCR had been invented. We were beginning to go into the serious acceleration of the technology of molecular biology. in the next 7 years, we're going to get to a place where we have the first complete sequence for an organism. That will be, all of that technology will be off patent. And so, we're beginning to get to a place where, a lot of the things that we would like to do have patents which are expiring. And patents which are expiring are extremely interesting in the sense that they have well-defined boundaries. You know, or presumably the patent office thinks that you should know whether you're violating that patent or not. And because they've expired, you now have certainty looking backwards. Somebody thought that that was a valuable idea. Now it's an idea that you can get to use. So there's a very interesting place there. And we ought to talk about the idea of families of parts. That's another problem with this idea that each part is a DNA sequence and stands all by itself. The real value for a lot of the parts that I see is that it's a member of a family of parts. So you have the collection of Chris Anderson's promoters, you have the collection of ribosomal binding sites, you have collections of different kinds of fluorescent proteins with different colors. You have the same protein coded for by codons that are suitable for several different organisms. All of these ideas that you don't think about individual parts or individual DNA sequences, but whole sets of parts. And finally, an idea that I know Jonathan's going to spend some time talking about. So we really need the good interfaces for the simulation technologies, and if you've got individual parts that come from who knows where, with descriptions that don't have the right features in them, or just have DNA sequence, you're not going to get very far with that. So these are some of the things that I'd like to get out of this morning's session, and I'll ask for the volunteers who are going to step up here and tell us how we do this. So who's first? Oh, come on.
Maybe this discussion about what is a part could be just so that we know what we are talking about.
And what devices, what's the operational definition?
Well, I'll be blunt with you. I've never particularly liked that distinction, and the difficulty from an engineering standpoint is one man's part is another man's device. So there's a hierarchy of these things. And to make a binary distinction, this reminds me of a joke that is common in the computer science and engineering community, is that that whenever the good engineers, the way they count is 0, 1, infinity. There's never the place where there's 2. If you're doing something twice, you probably ought to be thinking about doing it as many times as it takes. And so when you make the transition between a part and a device, well, that's 2, and it really ought to be as many devices as it takes on top of that, as many layers in that cake as it takes. And you just have to be much more careful about now defining exactly what those interfaces are, and defining what it means to you want parts that are you want devices, I guess, made out of other devices, and that seems to me an absolutely critical part of the technology.
I think so. We had this discussion, and what we came up with is to say that the device is something that has a defined input and output.
Yes.
And the part is a more general term for all those things, and then the sequence equals part is more something that you should say if you talk about biobricks as a more concrete version of a.
But I gave you several reasons why that isn't really what you want. You really want these families of parts.
Yeah, sure.
You really.
Talk about a concrete something that you have in a tube, some piece of DNA that you have in a tube. You want to slide it
Yes, I mean, it's clear that you have an equivalence between this piece of DNA in the tube and the sequence. I don't think anyone will disagree with that, except maybe if you're making a library and then maybe there's many sequences in the tube. But roughly speaking, I think that's right. Now the question is, do you call that a part or not? And
you should take this breath part out of the game.
well, that could be.
This is a general term that we use. But if you want to be concrete, then you say, okay, this is a biobrick because it has this format, it has this sequence, and that is that. If we talk about engineering, biology, we talk about parts, and that they don't have to be biobricks, right?
Well, that's right, but you really want the ability to think about them as families of parts, and you really want those linkages between parts to be critical. If I have quote the same part unquote implemented in different technologies. I have GFP, but there's the GFP that expresses well in yeast, and there's the GFP that expresses well in bacteria, and there's the one which degrades rapidly. And
we had also in the CF workshop, we also came up with the definitions of families.
Right.
We realized the problem. And
Yeah.
tried to,
Yeah.
But you see, we have two different things. So we have one thing, how you talk about it, and then you have the problem of defining a data model. And I think we maybe mixed those two problems too much. That for a data model, you have to be very concrete. So is it a sequence? Is the sequence defining the entity or not? And then we said, okay, for biobrick, yes, it is defining the entity. So then,
but
if you talk about it,
I think we even have to be a little bit more careful than that. Is it the sequence that's between biobrick ends that is the thing that's valuable, or does it include the scars? Is it the whole plasmid? Is it what is the part? And in my mind, it's very unambiguous, which is it's the thing between the scars. And but there did seem to be some confusion, at least in some of the things that I read, about what people meant when they said, oh, it's the DNA sequence. If I take that same piece of DNA between the scars and I put it in 3 different plasmids, are those 3 different parts or not? In my mind, they're absolutely the same part. And but there did seem to be some sentiment in the community that perhaps that wasn't right. And so we should make sure that we understand and agree on that as well.
I don't know if there's any ambiguity as to whether define a particular sequence as a part. So the object that is a part is a DNA sequence. It's a string of ATC. It's a text string. It's not a blob of DNA in a tube. It's not a plasmid. It's a sequence string. And if you see that then in every other plasmid, then that plasmid would contain that part. But I think the distinction between like the COBOL scheme and what you guys are talking about is you guys don't want to include format as part of the part code.
No, I'm happy with formats. I mean, we're going to have several different formats. There's your format, there's the Freiberg format, there's the historical format. There's the new proposal that I have on the table for reworking the current formats. So it's critical that we get a format in there.
The way of defining part in terms of the data structure in the COBOL scheme, a part maps specifically to one format. So
which I'm not so sure about any longer.
Yeah, good, because I'm not so sure about that either.
In my own database, I now figured that it's actually more practical to have the format plasmid, or the structure containing the part. Then you can have the same sequence in different formats, it's still one and the same biobrick. But you have different implementations of that, basically, depending on which plasmid it is.
That's the key word, implementation.
Yes.
Part implementation, a format plus the string of DNA.
For instance,
And then the actual part actually captures the functional data about what that is.
Exactly.
I would say, obviously we all think that there are a variety of things that are important, and we basically agree on what those things that are important are. How we group them into which, like, we'll take these 5 things that are important and call it a part, or these other four things and call that a device, that's where the confusion comes in. I mean, obviously we need families. Obviously we need to know what the sequence is. Obviously we need to know where the format is and how. And when we're trying to communicate, it seems like the word part and device are becoming less useful because everyone sort of groups different important things in with each term.
Yeah, well, I mean, getting the nomenclature under control is part of why we're here. So.
Right, there's part and device, and there's part and composite part.
Yeah, part is to get another.
That's another one, yeah.
And there, one has to do with like functional composability, and one has to do with physical composability. And definitely, in terms of just maintaining a database of a collection of stuff, it's definitely useful to have a distinction between basic part and composite part.
Is it?
Well, I think it is. Yeah.
I mean, but where do you break that down? I mean, is a protein domain? Is that a part, and then a whole protein is a composite
So
part?
you're again getting into more like the conceptual definition of what's in that sequence and how you break it down. And I agree that's where it gets fuzzier as to whether there is a distinction. But in terms of in a biogrid scheme where there's this scar that strictly defines the boundaries between parts and how they connect to one another, there is no ambiguity about what the part is. It's the part's the thing in between the scars.
Well, what if
Some people mind
you can have it like a non-scar format, right?
Yeah, you could have
You could have a format
That's right.
that doesn't, and then you
That
have a
just
long
means-
sequence.
Zero star.
Yeah, that just means it's harder to figure out where the part boundaries are, right?
Exactly.
Yeah.
Or you take the information and you synthesize a whole new string and put it in a new format. And you leave the scar out.
Right. That's perfectly fine. Yeah, we should spend some time talking about the limitations of assembly with scars, and what the biological effect of those scars is. It's nice to have the illusion that the format, as it were, didn't make any difference, but it does. We all know that, and we should be thinking about what the impact of that is, and how we deal with that in terms of some of the tools that we'd like to build on top of this. Some of the simulation tools, some of the tools that allow us to analyze these sequences. So.
Yeah, I'm just I mean, I'm still.
Well, maybe we should think about what are the things that we would like to come to consensus on.
What is a part and what is a biobrick, and how does that complete the sequence of that?
What is the device?
And what is a device?
I don't really care about what the definition of device is. So now, it's
So this is in the literature.
well.
And people are asking can you explain it? And I find it very difficult to explain it.
Well,
It's not in the literature.
it's a black box, right? And it's the standard thing you have in electrical engineering, where you draw the black box around the set of components, and you identify what the inputs and the outputs are, and you promise not to look inside unless you're forced to. And that seems like a perfectly reasonable definition. I don't see any problem with that. It's an unfamiliar one to the biology community. That is the issue. And I think we've faced the problem that we've ignored largely the very important, in my mind, idea that these can be hierarchically composed. And so I think that's a pretty serious omission in terms of the way that people think about these.
If you define it as a black box with some input and some output, then defining the behavior of this black box is very difficult. So depending on the context of the sequence, if it is in the chromosome or if it is in the plasmid, depending on the physiological state of the cell, if it is like almost dying because there is no food, or if it is actively growing, then the behavior of this box changes probably significantly.
So
I think the concept of the device is sort of ahead of the science.
that's exactly right. And so ideally, what you'd like is a set is a data sheet. We have some good examples of data sheets at this point, thanks to Barry Canton. we would like a set of data sheets that tell you, oh, this device is going to be a perfectly good flip-flop or NAND gate, and it's going to function in these environments. And if you try to chromosomally integrate it, then it's not going to work. Or if you try to use this in yeast, you'd better be prepared to change it, to change the fundamental pieces that it's made out of. And the powerful tool that we have in electrical engineering that we haven't really tried out because I think the technology is not there yet to do it, is the idea that the device is a description of how it is built out of unspecified more fundamental components. So, if you're building a flip-flop, you might not want to, that's not a DNA sequence, right? I mean, in the ideal case, the device is not a DNA sequence. It's a description of the subparts and the functional behavior of the subparts which you would use to make such a part. And we're not there yet. We're not there yet in a serious way because we don't have many examples of interchangeable, simpler parts. Think about the last time you were perfectly happy substituting lac-I for C1 in one of the systems that you're building. Well, functionally they're pretty similar, supposedly, right? They're both repressors. It should be possible to, take out one, put in the other one, push the button, and go. How many of you tried that? Not me. Right? But in principle, one should be able to do that.
I think in a metabolic engineering space, you see a lot of that.
Yeah, you're starting to see it.
Replacing one variant of an enzyme with another, but recognizing together it's a mesalamine pathway.
Right.
Mesalamine device.
Yeah, you're beginning to see that, but we're in a pretty primitive state with respect to that.
I think, for me, to a large degree, the issue is that when you draw that black box, you lose a lot of information, and then if you have
Thank
two
God.
black boxes,
That's the idea.
right? you have two black boxes. They use the same smaller part, and you don't know that. You put in a plasmid.
Yeah.
Now you run the risk of your plasmid
Right.
combining.
The computer program will know that.
That's right. So now we need the compiler, and Jonathan, if I can get him up here, is going to tell us how to do that. But yes, we desperately need the CAD tool, which solves that problem, and that's an important thing. We need that. We know we need that, and that's part of the technology which we have to be developing. You want to talk? I feel like I've been talking too much. I'm going to shut up. Listen. Here. You're driving.
I can drive for a little bit. One of the things that we were really worried about in the beginning when we were working on building CAD tools was exactly the last two things we were discussing, which pretty much the ability to generate new parts from the library of subparts that you have. So if you have a description of an inverter that is sort of in the POPs world, sending POPs in, getting out your repressor protein, the site that it lands on, and then going from there. If you could have that description and then generate lots of subparts based on a library of zinc finger proteins or something like that, if you have a massive library of these subparts but you don't have the inverters built, then that would be something that the compiler could handle. It could say, okay, I've run through the list of built inverters that I have. Let me go search subparts and see if I can put something together. So there actually is support for that in BioJade. And the other thing that goes along with that is the understanding that parts have incompatibilities. So if they have the same protein that they code for inside, it's obviously not going to work in concert. So it maintains a list of all of the internal protein coding regions that all the parts use. And then it can, through constraint propagation, get rid of incompatibilities. So in the end, you have a system that theoretically should work. Whether or not it does, I don't know. It's up to your hands. But I think we need to go in the direction of capturing as much information about the part's performance and stuffing it in a database in machine-readable format so that you can translate it into simulations, and so that the compiler, if you're going in that direction, can understand what you're trying to build, what are the incompatibilities, and make it so that your entire system will work together. We're not there yet. The library of parts that we had to work with when we were creating BioJade was probably about 100 in the parts database. Probably less. And so, we sort of had to test by the seat of our pants with what we had. I think it would be interesting to go back and revisit that. And there's been a lot more interest in CAD tools now that we actually have parts and are doing interesting things with them. Which I guess would lead to one of the other topics, and it's a bit of a pain to discuss, but that's having a more open parts registry, because the original parts registry that I created with Tom and Randy is now closed. It's closed to people trying to read and write. And this causes problems for BioJade because BioJade uses it as persistent storage. So your designs are all stored in the database as a new part with all the associated simulation data, with all the associated schematics that you're building. All of that is stored as XML in the parts database and associated with the part. So the real question is, how do we get up and redo the parts database in a way so that it's accessible via the web, because we want people to be able to see what other people are working on, or you at least want to access it via the web. It's convenient. We also need machine-readable interfaces so that whatever design and simulation tools people are making, they can access it. And I think that is extremely important, because I can create a new tool and it can sit on my computer and other people can make use of it.
So yeah, three issues that I'd like us to explore. One is talking about the interchange, whatever that common format is, bubbles one. Another thing is more directly related. I think you guys should talk about your IGM team's project to scrape the registry and turn it into a format. Can you want to do it now? Sure.
So I guess one question is, scraping a registry is a rather inefficient way of getting the data out.
Well, we know that was the
It would be really great if Randy could just give us a dump of the
I
SQL.
can't believe that we do this in academia all the time.
I am only the messenger here, but I had understood that that was that the dumps of the registry were freely available. Now, perhaps I'm just naive and listening to Randy on a day-to-day basis.
He's been saying that.
There is a web interface to get the information off the registry. It's just the way it's organized. I mean, the sequence is...
It only gives you 3 pieces of information, right?
Yeah, the information it gives you is like, it doesn't give you sequence information. You have to parse the HTML file to get the sequence, which is not the standard way of storing sequence. And
Really? I thought it was.
and there's, just the information there is most of the information. So we haven't, as one of our IGEM students, he's converting like the registry to COBOL format. He has a web interface, which I can't find a website for. Then you just click a button, it converts the register, like BioBrick files to COBOL format.
Right.
So basically, you have to parse HTML files to do that.
You email that out to the standards mailing list?
Sure.
Standards mailing list? We can give a chance.
Yeah.
Okay.
So I think on the to-do list would be creating perhaps maybe a Java or a Python or Python object that would encapsulate a BioBrick object in COBOL. And
Well, we need to work generic on that. I would like to see either something like a web service or a REST service, something.
well, that's connected to the parts database itself. But we need that object so that it can serialize and deserialize.
But I can programmatically access the registry.
Yeah.
So they have to go via the HTML. And then they can do whatever they like on the back end.
Yeah,
What the API says.
No, but that can also be useful. Would be useful to have a little.
If you have the object, then the people who are writing programs can use that.
Right.
Um,
Different classes.
So I have a XML object that handles the XML format that I had done with the registry and BioJade several years ago. That's freely available if you guys want it. I don't know if it's obviously not compatible with POBOL, but it's a good start.
It seems to me the key thing here is to spend time getting the API correct. And I think one of the concerns is that we don't want a naive implementation or a poor implementation of something that we're going to then build upon.
Yes.
We want a solid foundation, and I'm not sure quite what the political maneuvers are that get us from where we are to that place. But you want.
It's also not only political maneuvers, we also have to work.
Well, that's right. So there's a combination of genuine work together with probably with some politics that's required to pull this off. And the question is, I think the real thing we need to do is to figure out what it is that we would like to see in terms of features at the end of the day. And it's a complicated thing. It's easy to think that this is a simple problem, but it is not. It's hard to do it right. It's hard to do it, with the correct balance of openness and reliability. It's hard to do it, in a way that doesn't effectively get spammed. It's hard to do it with, attribution of who is actually being the contributor. I don't think these are easy problems. I know that they're not easy problems.
Well, maybe it's easier than you think, though, because I come from another community, the SPML community, and there's a whole infrastructure that's arisen. But we didn't design everything out front and then implement, because we knew that would mean it would take forever, and it would never be done.
Actually, I sat in some of those meetings,
Yeah.
and I have to tell you, they were pretty much, we will design everything at the beginning.
No. I did the first draft. It wasn't done that way. It wasn't definitely done that way. The first cut was done level 1.
Okay.
We knew it was incomplete, but it drew people in. There was enough for people to get going. And then it went on multiple levels, and other people took over. And now it's the most successful standard system as well.
So the real question.
It's simple. That's it.
Well, the real question, so you were successful in that community. How many false starts were there in doing that? Ones that you weren't involved with, that people went off and tried to do that.
None that I know of.
But I think there were. I think there were a lot. Oh, come on.
No,
There was the whole DARPA biocomputing program. And
Well, I think the key here is to get something that we can all agree on. I think a lot of the people in the room are representative of the community.
So one suggests, so we have this data model issue, that is one thing, and then we have this little POBOL mailing list. It's not much more than that. We have some suggestions on the table, so it's not closed, it's not whatever, it's completely handleable. But it could serve as a platform to discuss about the data model. And then another suggestion that was popping up was to come up with an open source software library, like a BioPython for synthetic, or BioJava, or whatever, for synthetic biology.
Absolutely.
So one of the first items in that library would be representation of the BioBrick in different languages. And parsers for data models. But that would be, you would have 2 access points, one for programmers, one for the database administrators, to actually join the effort. So that would be a...
So I think in order to do that, we would need a freeze on POBOL level 1. Right. So if people
decide where to freeze it. Yeah. If there's anything missing from it, I would definitely recommend the first level just to get out there. In a year or two, we'll find problems with it, and we go on to the next one.
Well, I feel like there have been comments made that there are problems with COBOL, and I haven't heard them clearly articulate as what specifically the problems are with it. And I like to have that discussion as a community that was more open. I feel like COBOL has thus far been discussed in small groups, and you have different intersections of small groups, but just having this all-out people articulate specifically what they don't like about this model, and then seeing, is there a better way to do it just from at that core of just those 5 objects that are in there.
Mac, do we have? Yeah.
Yeah, I need battery anyway. Or I guess at times.
Yeah, you just disconnect that.
No, it's
Oh, it's on the web?
This is good because it shows it on the way through.
I think we also need to make a distinction with code. They're 2 kind of entangled ideas. They're necessarily entangled, like we had this discussion
Maybe
before.
more than
They're
2.
necessarily entangled. One is just the representation of biological objects. And then 2 is this whole RDF thing that is the sharing mechanism. And they are entangled because they are fundamentally entangled, but they are separate ideas. And you can have the representation of objects without the RDF thing.
The
I think we need to discuss
RDS
those
is
and
just
just recognize that
that.
those are
It's
It's not a salient point.
That's right. Yeah, it's like deciding whether they should be punched on cards or on paper tape.
Well, I mean, the entanglement comes in for certain things you can do in RDF that you cannot do in a strict table structure.
I think it's also just how we're going to share these files between people. Is it just an XML file, or is it something more than an XML file?
I don't think it should be a file at all. I think it should be a database.
But I have strong feelings about that.
Well, yeah, so there's some sort of programmatic.
Absolutely. And now the thing you fetch from the database might very well be in this format.
Yeah.
Right.
I have no problems
So
with
that's
that.
the
But
file. But then it's safe. Like, for example, the way we've been talking about implementing
It's just a serialization. It's not a file.
Berkeley is we have our own databases at Berkeley that are just MySQL databases, normal databases, and then somehow there would be a little program that sits on top of it that turns it into
Right.
the XML thing whenever it's asked for it. So the thing we have to decide as a community is that XML thing.
Right.
I see the value of that, but there's value associated with a lot of stuff that's not represented in that form. So you have to tell me, for example, how I define a family of parts in this format. You have to tell me how I'm going to design.
Number 11.
Why don't we talk about that? 'Cause I think that is the thing that has been the primary criticism of COBOL is how families are represented versus what's represented. And maybe we should talk about first of all just how what the idea was.
And it's extremely important to get these ideas right. If you screw this up, you are in serious trouble, not just this year, but 10 years from now.
But
I know
anyway,
this
this
is
is
dark.
our discussion.
I mean, you're right.
No,
You're right. There's a
it's
potential
very
for that. There's a
important.
potential for that. If the community is small, we can easily transition over to the next one.
Yeah.
Depends how big the
People
community
said that
gets.
with IPv4.
Yeah, it depends how big the community gets and unwieldy it becomes.
Well, hopefully it will become big and unwieldy.
Exactly. That'll be the problem, yeah.
So
So Ju-
basically, 2 modules, so you have that schema there that is centered around the BioBrick. And there are 2 modifications that have been discussed. So one, it's not my idea actually, one is to take BioBrick format into the DNA rather than into the attached to the DNA. So that the BioBrick is basically rid of the format thing. Which I first didn't like, now I like it more actually, but so that is something
You want to go for your type, right?
huh?
You want to go and type?
Yeah.
So there's a
So
question that
the sequence has to be pushed down too.
Whether we want to discuss it now. And then the
There's a question I wanted to bring up in general, which is, I mean, I think most people would agree in this room that
the science is sort of behind the standards that we are trying to create. If we want to accurately describe a part by its function, can anybody give me a part that's guaranteed to maintain its function regardless of where you put it? I don't think the science is well understood. Or what exactly descriptions do we need? What all descriptions should go in a part in order for somebody to model it or somebody to reuse it accurately and know all the side effects?
I think we need a more defined description of the parts parameters. So the operating position, the level. Yeah.
But see, I would argue that it's level 2.
I think that's essential.
A standard that's adaptable,
So
that as science changes, we can adjust the standards without, just throwing away the database and recreating it.
So it's not something that necessarily needs to be in every part, right? Because not all parts will have that data anyways. There's no way.
Yeah.
But it's something that we should think about capturing and decide how that would be represented. Not necessarily in the database, but at least in the interchange model.